So anyway, guys, I'm recording this right now. Some of the stuff on the whiteboard you will not see. What you'll see is my screen. You'll hear my voice the entire time. So it's just a reference for you. I will then post that on my YouTube channel. To get to my YouTube channel, just go to YouTube and do a search for Verser, V-E-R-S-E-R, and this stuff will show up. It'll be tagged. Typically, the way I'll send out because I'm going to record all the Capture One lectures. I'll send you guys the link to the first one, and then you can see the naming convention that I use. So it'll be something like Digital Tech Fall 2019. Whatever this is. Are we in session 6? Is this our 6th? Yes, it'll be session 6. I'll break it up into parts. So for instance, I'll record this part until we get to break. I'll stop, and then after the break, I'll start recording again. So there'll be a part 1 and part 2 for today, that kind of stuff. So it's pretty self-explanatory. If you want to go through and watch it again, you're certainly able to do that. The first part of this, you're only going to hear the audio. You're not going to hear, well, no, I take that back. You will see the video. So at any rate, I just wanted you to be aware of that. All right, so in the conversations that we've had so far leading up to this class, I have done everything I can to stress to you how important exposure really is. And the issue is that most people think that digital is so much easier than film ever was, that film was more critical for exposure, and you couldn't be more wrong. Film actually has let's phrase this. There's 2 different kinds of film. There's transparency film or positive film, slide film, that is very unforgiving in terms of exposure. If you are overexposed by half a stop, it's unusable. If you're underexposed by half a stop, you can actually push process and you'll be okay. If you're underexposed by full stop, you can still push process. It'll be a little grainy, a little contrasty, but you can still get away with it, whatever. However, color negative film and black and white negative film, whatever, have an enormous amount of latitude in them and a great deal of forgiveness. And everybody thinks digital has that same forgiveness, and it does not have that same forgiveness. And so what I'm going to show you now is why it does not have that huge amount of forgiveness. So what we need to do is we need to talk about the difference in what we call linear capture and logarithmic capture. So I'm sure everybody's heard the word logarithmic at some horrible place in their high school math class, and they didn't understand what it meant then, and they don't want to understand what it means now. And I'm right there with you. I understand exactly where you're going with. So I'm going to try to simplify that in a way. Don't worry about the name. Don't worry about the number. There isn't an enormous amount of math in here. There is a little bit of math in here, so I need to test everyone. So what is 10 divided by 2? What is 2 plus 2? We're good to go. So that's going to be basically the extent of it. I know, right? Everybody's just like, okay. All right, so at any rate, so this illustration, in order to try to illustrate what the problem really is here, I'm trying to simplify this in a way to make it as simple and easy to understand. So this is my idea of animation. They asked me to, anyway, people always are, anyway, never mind. This is my animation. So what I've got here is, there's a computer, and connected to that computer are 2 scales. And on the scale on the right-hand side over here, there's a 1 ounce weight on that. And you can see that it's reading 1 ounce, and the computer understands that part. It knows, again, it's just reading out the readouts of the scale. Does that make sense to everybody, what's going on here? Okay, so, sorry. So then I add the exact same weight on the other side, a 1 ounce part on the other side, and the computer understands that as well. Does that make sense? Easy, relatively easy, right? So in this case, so we've added the 1 ounce weight to the right side of the scale. How much weight does the computer really think I've added? And what I'm going to ask you is, does it sense, it doesn't matter whether they're ounces or pounds, does it sense the same amount of weight that was on the original right side? And the answer is yes, of course it does. Simple, right? No trick questions here. Is everybody good on that part? Okay, if I add a second weight, the question is not, are these the same? They are clearly not. The question is is this amount that was added the same as the original part? Does that make sense? Again, I'm not looking for total weight here. My question is, when I added this 1 ounce guy right here, did the computer understand that I was adding the same amount as was the original weight on the right-hand side? And the answer is yes, of course it knows. So again, it's saying, okay, he added another ounce. It was the exact same thing as the original part. Does that make sense? And I can do this again. Does the computer understand that this amount of weight here, just this top one, the additional weight that I just put on there, is it the same as this original amount was? Now, you know, I've got a lot more weight over here, and that's not the question. The question is, am I always adding the same amount that we started with on the original right-hand side, left-hand, well, in your all's case, left-hand side? Is everybody clear on this part? And this just keeps happening no matter how far we go, how far we go in doing this. It'll continue to happen. And as long as we do this part, everything is all hunky-dory. This is what we would actually call a linear scale. And so in this case, looking at this linear scale, you'll see that it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And what we mean by, or in this case here, it doesn't have to be single digits here. It can be 100, 200, 300, 400, 500. The thing about a linear scale, though, that you need to get in your mind is that the difference in any one of these two numbers is identical all across the scale. So the difference in 2 and 3 is identical to the difference in 8 and 9. The difference in 1 and 2 is exactly the same as 5 and 6. Does that make sense? The difference in 500 and 600 is exactly the same as 200 and 300. It's a linear motion. It's a linear scale. Everything is exactly the same. It just jumps up exactly the same amount no matter how far we go. Does that make sense, everyone? Who's not got that? What's the difference in 8 and 9? What? I'm sorry. So if you subtract 8 from 9, what do you get? If you subtract 4 from 5, what do you get? If you subtract 1 from 2, what do you get? 3 from 4, 9 from 10. It's all the same step. No matter where we are in here, it's exactly the same step, right? What's the difference in 500 and 600? If you subtract 500 from 600, 100, right? What if you subtract 200 from 300? 100, 100 from 200. The same, right? If I had 700 there and you subtracted 600 from it, what would it be? So the thing is that every one of these steps is identical. That is a linear scale. Make sense? Okay. Debbie, my wife, who was here this morning? Kelsey, you were here. That was my wife this morning. Anyway, this is my version of Debbie. Wearing a blind, right? So she can't see anything. She can just feel, right? Well, she can smell things, but anyway, she can't see anything. Does that make sense? Okay, and just like in the original illustration that we did with the scales, she has got a 1 ounce weight in her hand. And I add an equal amount of weight to the other side into her left hand. And so the question to you is, how much weight does she sense that I have added? Does she sense that I have added the same amount that was in her right hand? She might know it's an ounce or whatever, but does she feel like, okay, this weight that he just added was the same as I started with over here? And the answer is yes. Simple, right? This is where it gets tricky. I'm not going to add one more weight to her hand now. I'm actually going to add 2 ounces. I'm going to try to trick her. So the question I've got is, does she feel like, she'll know that there's more weight in this hand than there is in that hand, just like the scales knew that there was more weight. That's not the question. The question is, does she believe that this additional weight that I added right here equals the same amount of weight that she was holding in her hand? Does she think, okay, He just added the same amount of weight. Now, I know that this is heavier, but is the additional weight that he just put on there the exact same as what I'm holding in this hand right here? Do you guys get the question that I'm asking here? And the answer to this is yes. She senses that this 2 ounces is indeed the same weight as this over here. That's the way she perceives it. Even though it isn't, that's her perception. Does this make sense? It gets stranger, because that's pretty strange, right? I do 4 ounces in her hand now. Does she sense that I have just added the same exact weight that I started with over here? And the answer is yes. Her perception of this is that when I added these 4 ounces, she senses that I have added the same exact amount of weight that she's holding in this hand. Again, she knows things over here are much heavier than in her other hand. What I'm asking is, when I drop that 4 ounces on there, does she perceive it, oh, he has just added the same amount of additional weight that it was in my original hand? Does that make sense? This goes on. 8 ounces now. She senses that as 1 ounce. 16 ounces now. She sees that as 1 ounce. Do you guys believe this? It goes on. If we were to continue that whole process, the next one would be 32 ounces. The next would be 64. It doesn't end. This is what we call a logarithmic scale. A logarithmic scale is exponential. Don't worry about it. I'm going to show you guys and tell you what exponential is. But this would be an example of a logarithmic scale, and it's just a doubling. So here, you start with 1. What is 1 doubled? 2. What is 2 doubled? What is 4 doubled? What is 8 doubled? What is 16 doubled? And what is 32 doubled? Exactly, that is a logarithmic scale. And the reason it's different than a linear scale is, if we look at the difference between 32 and 64, this is one step here. The difference in those two is 32. But the difference in 2 and 4 is only 2. So unlike the linear scale that we looked at, in a logarithmic scale, you have these much larger gaps as it's starting to go up. Does that make sense? Are we good on this part? So this is what a linear scale looks like. Again, the distance between any of these two numbers is identical to any of the other two that are neighboring it. However, in a logarithmic scale, that's not the case. So this is a hint. Is there any logarithmic scale that you guys have been working with your whole photographic career? What would that logarithmic scale be? It would be fstops. Aren't fstops logarithmic? What is the difference in one f-stop and the next? Having or doubling, right? So we're going to look at our board up here at the whiteboard. Can everybody see this guy? Time to recite our f-stops again. And I'm going to be kind to you. I'm going to only start at f2.8 because nobody likes starting at 2. But I'm going to start at 2.8. If you can't see this, I'll bring this around as much as I can till it starts to invade the screen. So scooch around if you need to be able to see this. Okay, so let's start at f2.8. And I'm going to start to stop down, right? I'm going to close down my aperture. What happens when I close down my aperture? Less light. And what else? What's another sort of consequence of doing that? Greater depth of field, right? So you guys have got that part. Okay, so what's the first stop down? Next stop down. And again, and again, 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 One last one, 45. If you want to go to the last one, 64, only because you all know about the F64 club, but nonetheless, I'm going to leave off the 64. So, doubling and halving, doubling and halving, doubling and halving. I'm going to say here at F45, it will let in one photon of light. One particle of light. That's all it lets in, F45. Does that make sense? How many particles would it let in if I open up to F32? Doubling and halving, doubling and halving, doubling and halving. What's 1 doubled? 2. If I open up to F22, how many particles of light come in? 4. If I go up to F16, how many come in? If I go to 11, how many come in? If I go to 8, how many come in? If I go into 5, 6, how many? If I go to F4, how many? And if I go to F2.8, how many? So this is a logarithmic scale. Does this make sense to everyone? So again, what's happened here, and if you look at this, the difference in 1 and 2 in this part of my scale right here is only 1. The difference up here, though, at 64 and 128 is actually 64. Does that make sense? However, if you were to actually use this to photograph, you would end up with a perfectly even gray ramp. You would not see a really small move here and a giant move here. This thing would look as a consistent gray ramp, gray scale, wouldn't it? It does. Does this make sense to everybody what's going on here? This scale was developed based on your eyes. Your eyes see logarithmic. Your feeling in your hands is logarithmic. Your sense of taste is logarithmic. So another example, I've got a cup of tea and I put in a single sugar cube and I taste it. And I say, okay, I want it sweeter. I want to double the sweetness that is in this cup. Now, typically you would think you would simply add another cube of sugar in there, but that's not the case. You need to add 2 cubes of sugar to feel, to taste the sensation that indeed the sweetness has doubled. If then again you say, well, I want to add another cube of sugar amount of sweetness, the next version is you need to add 4 cubes of sugar to do it. Guess what the next one would be? 8 cubes, because your sense of taste is logarithmic. Your hearing is logarithmic. You guys have heard of decibels, right? Oh, that was so many decibels or whatever. The difference in 16 decibels and 17 is a doubling of the volume of sound. Again, your senses are logarithmic. Your hearing is logarithmic. Your eyes are logarithmic. Your taste is logarithmic. Your hands, your feeling, your touch, all of your senses, if you believe in ESP, it's probably logarithmic as well. Does this make sense, everyone? So we need to embrace that part, but we also need to understand that there's a really upside for us, but there's a really bad downside for digital in this regard. So are there any questions about logarithmic about this? Are we good? All right. This is the difference in what it would actually look like. So if you look at the little blue guys right down here, these little blue guys actually represent a linear scale. So again, what we've done before, when you go from 1 to 2, it simply doubles, 2 to 3, it doubles, 3 to 4. But again, the difference in the height that we're growing here, the difference in 4 and 5 is identical to the difference in 2 and 1. The difference in 8 and 7 is identical to 4 and 3. That's that linear scale. But look at the difference that happens in a logarithmic scale. The difference in 1 and 2 is the same in the beginning, but once you get up here, the difference in 7 and 8, it's a gigantic leap here in this difference. Because again, my steps in this logarithmic scale are a doubling. And the reason this is important to us as human beings, we've evolved this way. Look at the difference in the range that your eyes or your taste or your ears can sense. In 8 steps, I go from that little bitty thing on the left-hand side all the way up here to the top. This is a gigantic range. I go from 1 to 128 in 8 steps. But a linear device, if I was linear, we're not, but there are linear devices, and that same amount of movements goes from 1 to 8. So for us, we're actually able to go out, and you guys have experienced this. You can go out on a sunny day and look at the sun reflecting off the chrome of a bumper of a car, and also see the detail on the ground in the shadow underneath the car. You can see detail in both of those at the same time because your vision, your range of vision is extraordinarily huge. And it is because you see logarithmically. Does this make sense to everyone? It's just our range is just enormous. Are we good on that part? So that part's really good. However, you can take a linear scale and put a curve on it. And when you do that curve on it, you can fix it mathematically so that it matches a logarithmic scale. So you can get a linear scale to imitate it if you actually put a curve on it. Now, everybody in this room has used Photoshop, right? And you all have, has anybody in here never put a curve on an image in Photoshop? What does a curve do? Of course.